Hello everyone, welcome back to my organic chemistry mini lecture. Today I will talk about the absolute configuration. And that is the configuration of the asymmetric center of the organic compound. So what is asymmetric center? Usually that's an atom. Most of the time it's carbon with 4 different attachments. The attachment could be atom, could be group. For example, if you look at this compound, this is the chloroalcohol, and the methyl group here, the carbon cannot be asymmetric center because this methyl group's carbon has 3 hydrogen. That's the same, and they only have 2 different type of attachment. So hydrogen and the other carbon. Same thing as here, CH3. They have 3 same group, same atom, hydrogen. And this carbon has 2 methyl group. That's the same. So this carbon has 3 different attachment: methyl, chloro, hydroxyl. So there's no asymmetric center in this compound. If you change the methyl to ethyl, then we have an asymmetric center here. That's not, we just said that's not asymmetric center. This carbon cannot be because you have 2 hydrogens. That's the same atom. And this methyl cannot be the asymmetric center because that's CH3. The 3 hydrogen, they are the same. So this carbon has 4 different attachments: methyl, ethyl, chloro, hydroxyl. That's why this carbon is asymmetric center. Sometimes we call it chiral carbon, so same thing. And now if you have a cyclic compound, you have a methyl group on this cyclohexane, and if you see the dash, that means you have hydrogen pointed to you. That methyl is away from you. Now this carbon is the only possible asymmetric center. The other 5, they are CH2. So apparently they have the same hydrogen, right? 2 hydrogens. Now this carbon has a hydrogen, methyl, that's different. And these 2 CH2 are same. Now you look at the further attachment, that's also same. Further attachment is here, CH2. So basically this carbon has 2 attachment here. So that's not asymmetric center. If you change this methyl, the single bond to double bond here, then situation will be changed. Again, you have a methyl group point away from you, so you should have a hydrogen pointed to you. So this carbon will have hydrogen, methyl, and then these 2 attachments are different. See, this is a carbon with 2 hydrogen connect with another carbon. This is a carbon with 1 hydrogen connected with another carbon by double bond. So these 2 different attachment are different with hydrogen and different with methyl. So this carbon has 4 different attachments. So that is asymmetric center. Okay, now let's have more examples and find the asymmetric centers. First, you have this another cyclic compound with 2 methyl group here. And then look at this carbon. First, we know that's not that one, this one carbon, they are all CH2. They cannot be asymmetric. Now look at this carbon. This carbon should have methyl and hydrogen away from us. That's 2 different attachment. Now these 2 looks like the same, CH2, but if you look the further attachment, these 2 carbon are different because this carbon have a methyl group here. This carbon only 2 hydrogen, so that's different. So this is asymmetric center. Now look at the other carbon, this carbon. So look, now we all know this. We already know this is asymmetric. Now what about this carbon? Same thing. We have a methyl group, so you should have a hydrogen pointed to us. I didn't draw it here. So now you look at these 2 attachment, they look like the same. But if you look further attachment, that's different. So this is also asymmetric. Okay, center. And one more example here is a linear with a compound, not cyclic. Now look at this carbon. This carbon has methyl, another methyl, so this carbon is not asymmetric because you have 2 same group. You must have 4 different group. And then this carbon, Actually, it is asymmetric because you have a hydrogen away from us, methyl, and these two carbon look the same, but if you look further attachment, that's different. So that's asymmetric. Now, same as here. This is also asymmetric, this carbon, because methyl, hydrogen, two carbon look the same, but if you look further, this and this one, these two carbon are different. So that's why this is also asymmetric. Now, this is also asymmetric because you have a methyl, ethyl, hydrogen, and this whole group are different with the other three group. So this is also asymmetric center. So this compound have three asymmetric centers. Now, last example is this epoxide here. So this carbon, it is asymmetric center because you have a methyl and hydrogen away from us. And look at these two attachment. Although they are tethered here, but look at this two group or attachment. This is oxygen, this is carbon. So that's different apparently. So this is 4 different attachment on this carbon. So that's its asymmetric center. Now, let's talk about a rule because before we able to assign the absolute configuration, which is R or S notation, we need to know the priority of the attachment. So first, the name of the rule is called Cahn-Ingold-Prelog. You can call it CIP priority rule. Rule number 1, higher atomic number, or if it's isotope, higher mass number, will have a higher priority. For example, carbon is higher than hydrogen. Atomic number is 6, atomic number is 1. Oxygen is higher than carbon. Atomic number is 8, carbon is 6. Bromine is higher than chlorine. Bromine atomic number is 35, chlorine is 17. Deuterium and hydrogen. Deuterium and hydrogen, they are isotopes, but deuterium's mass number is 2, hydrogen is 1, so deuterium is higher than hydrogen. Carbon 13 is higher than carbon 12 because mass number. Okay. Second, for same atom or a tie, if you have a tie, then proceed down. Look at the attachment. Proceed down the chain to break the tie. So if you look at the further attachment, is still same. You have to look further. So you keep going until you find the different. Okay. So for example, ethyl is higher than methyl because first carbon is the same, but the attachment is different. And this carbon has 2 hydrogen connected with another carbon. This carbon connected with 3 hydrogen. So this is higher because 2 hydrogen cancel each other even, but the third attachment is carbon compared with hydrogen. Carbon is higher than that hydrogen. Now this group is higher than this group. This is methyl alcohol basically. This is the propyl. First carbon, it's a tie, but if you look at the further attachment, you have oxygen here. You have another carbon here, the 2 hydrogen even. So this is higher than this group. Third, multiple bonds. That means double bond or triple bond. They are treated as multiplied bond. For example, a double bond can treat it as 2 carbon-carbon single bond. So that, of course, is higher than this ethyl because this is just 1 carbon-carbon. Okay, so now let's look at some examples. First, this is an alcohol again, and we have the rule, and we can assign the priority. Look at this hydrogen, fluorine, carbon, oxygen. That's the first atom. Based on the first rule, the atomic number, fluorine is 9, oxygen is 8, carbon is 6, hydrogen is 1. So it's already make the fluorine first or highest priority. If you see hydrogen, it's always number 4, lowest priority. Okay, so now compared with these two, oxygen is higher than carbon, so that's second, okay, high. Now carbon is number 3 priority, and the lowest is 4. So it's already can tell. Now how to assign the R or S notation? The rule is you must put the lowest priority group away from you. You have to put this number 4. Sometimes the hydrogen, sometimes it's other group, but the lowest priority must be away from you. So how to do that? That's the easiest way to just look at this molecule from bottom. If this hydrogen is point up, so look at from bottom. So you will see fluorine is to the left. This hydroxy group will be to the right, but pointed down. methyl will be point up to your right. So now the priorities are still same. So this is 1, this is 2, this is 3. So now after you see this, then you have to look at this direction from 1 to 2 to 3. What is that direction? It's counterclockwise, so it's S. So if it's counterclockwise, it's S notation. If it's clockwise, it's called R notation. Okay, so this asymmetric center is S notation. That's called absolute configuration. Look at this example. We have a alkene, a double bond, alkyne, a triple bond here, and hydrogen and a methyl group. So if you remember, we know the multi-bond treated as a multiplied bond. So this should be number 1 because this carbon and this carbon and this carbon is a tie, but this carbon connect with 3 more carbon. This connect with 2 more carbon. This connect with 3 hydrogen. So this should be 1. This should be 2. This should be 3. That's the lowest priority. Number 4. Now, based on the rule, we have to put this hydrogen lowest priority away from us. So there's 2 ways. First, you can rotate this single bond, rotate this hydrogen away from us. That's how you do. And then you rotate this to here, basically 120 degrees. So that's well, hydrogen was here, then rotate here. So this triple bond should be rotated to here, here, and then methyl should be here. And then you look at this priority. The priority is 1. It's the same 1. Just rotate to here. That's 3. That's 2. That's 4. Now you look at direction. 1, 2, 3 is clockwise. So it's R. The notation is R. So this is the first way. Second way, you don't have to do this. You just look at this 1, 2, 3. 1, 2, 3 is counterclockwise. But since the hydrogen is not away from you, it's pointed to you. So you just change the counterclockwise to clockwise. Just flip it. Okay, so you get the same notations R. Okay, now look at the third example. We have asymmetric center here, and if we look at this first attached atom, it's nitrogen, carbon, carbon, carbon. So nitrogen atomic number is higher than carbon. It's 7. Carbon is 6. So this must be 1. Now compare to the other 3 carbon. Now they are tie, they are same, but look at the attachment. 3 hydrogens. This carbon with oxygen, so this should be higher than this. But this carbon has a double bond with oxygen, so basically this carbon has a 2 carbon oxygen bond. 2 oxygen compared with 1 oxygen, this is higher. So this is number 2. Now that's number 3. That's number 4. See, the lowest priority in this compound is not hydrogen. It's just methyl. It's okay, and happen to be away from us. That's nice. So they just look at the other 1, 2, 3. The priority rotation is 1, 2, 3 is clockwise. So this is R. So this is R notation. Okay, that's how you sign it. Look at more example like this Fisher projection. Fisher projection use the 2D line to show 3D. Okay, so if you see that, that can be translated to horizontal bond are pointed to you and the vertical as away from you. So this is a real 3D structure. Okay, but you always use this just a single line to show the wedge and dash. Horizontal are wedge, okay, vertical are dash. Now let's look at one by one. We have 2 asymmetric centers, okay, this one and this one. Let's look at one by one. For this asymmetric center, we have bromine here, carbon, hydrogen, and the carbon. So these 2 carbon are tied, but bromine is a higher priority, okay, atomic number. So that's number 1. Now compare with this 2 carbon. This carbon has an oxygen and another carbon. This carbon only 3 hydrogens. So of course this is a higher priority, number 2. Now this number 3. Hydrogen always number 4, lowest. Keep that in mind. Hydrogen is pointed to you. It should be away from you. But keep that in mind. 1, 2, 3. The rotation is clockwise. So you have to flip the clockwise to counterclockwise, because this hydrogen supposedly should be away from you. So that gives the asymmetric center here as S notation. Now look at the other, okay, asymmetric center. And now you have oxygen, carbon, hydrogen, carbon. So this oxygen atomic number is highest, number 1. Compare this to carbon. This carbon has bromine attached. This carbon, 3 hydrogens. So this is number 2. This methyl, number 3. Hydrogen, always number 4. This hydrogen is again pointed to you. Keep that in mind, okay? Now, rotation from 1 to 2 to 3 is clockwise. And this supposedly should be away from us. So then reverse it. Okay, it should be S. So this is S. S and S. Another example, we have a deuterium here. Okay, so now again, we translate this to the 3D structure and then to asymmetric center one by one. For this one, we have chlorine, carbons, and hydrogen. And for the chlorine, of course, highest atomic number, so number 1. Then number 2 is this carbon because this has other carbon. This only 3 hydrogens. Number 3 is methyl. Number 4 is hydrogen. Now 1, 2, 3. That's counterclockwise. But this hydrogen supposedly should be away from us, but this point. So this is R, clockwise. Same thing, do the other asymmetric center. So we have hydrogen, deuterium, ethyl group, and this carbon with methyl with chlorine. So apparently this is the highest priority. Then number 2 is ethyl. Number 3 is deuterium because mass number is higher than hydrogen. They are isotope. Number 4. So 1, 2, 3. That's counterclockwise. But this hydrogen is pointed to you. So you have to reverse it. So this is S. So that's S. So it's R. This is S. Now, this could be another kind of question, how to name the compound with asymmetric centers. For example, if you have this molecule with 2 asymmetric centers, how to name it? First, we can just based on the normal naming, you can give the name based on just the substitution, the numbering is 2 bromo, 3 methyl, and a pentane, not worrying about the absolute configuration now. But then you have to figure it out. So this is a basic name. Okay, then look at this asymmetric center. So we have bromine, hydrogen should be away from you. So although it didn't show, but you have to know that. So I'll draw this, and then we can assign the priority. Highest 1, 2, 3, 4 based on the CIP priority rule. Okay, and then look at the 1, 2, 3. The direction is counterclockwise, and this hydrogen is away from us, so this is S. You don't need to flip it or not. Okay, now look at the other asymmetric center. This asymmetric center, you should have hydrogen pointed to you. Okay, and hydrogen, methyl, ethyl, and this is the carbon with bromine. So this should be carbon highest priority. This is 2, this is 3, this is 4. 1, 2, 3, it's counterclockwise. However, this hydrogen is pointed to you, so this should reverse to R. So now we have the carbon 2 is S, carbon 3 is R. So you have to put that in a name. 2S, 3R, 2S, 3R, 2 bromo, 3 methyl pentane. That's the complete name. Another example is the cyclic molecule with 2 asymmetric centers. So look at this carbon 1. So because this hydroxyl group. Okay. First, we have the basic name is the 2-methyl cyclohexanol, and then we have to worry about the absolute configuration. So first, the hydrogen should point to us because this is away from you. So then we have assigned a priority. This is the highest, second, third, fourth, based on the priority rule, okay, the CIP rule. And then 1, 2, 3, it's counterclockwise. But this hydrogen is pointed to you, so you reverse it to R, clockwise. So that's the first asymmetric center. And then this asymmetric center is here, so you should have a hydrogen pointed to you also. Now assign the priority. This is 1, 2, 3. 4. Okay, and then 1, 2, 3 is clockwise, but this again, this hydrogen is pointed to you, so you have to reverse it to S. So the final name should be 1R, 2S, 2-methyl cyclohexanol. If you have the name with this absolute configuration, how to draw it? So now I'll show you how to do it. First, you just draw the basic structure without worrying about the absolute configuration yet. Okay, so just draw the 2-bromo 3-chlorohexane. 2-bromo 3-chloro hexane, and then you worry about absolute configuration. That this carbon 2 should be R notation. So let's pretend the hydrogen is away from you and bromine is pointed to you. Then we assign the priority 1, 2, 3, 4. And then what is the notation? 1, 2, 3. 1, 2, 3 is R. This R is exactly same, happen to be the same R required. So good, we can keep this. We can keep this asymmetric center. That means our assumption is right. Now look at the carbon 3. Again, we assume hydrogen is away from us. Then assign the priority 1, 2, 3, 4 based on the CIP rule. And then what is this notation? 1, 2, 3 is clockwise. It's R here. But your question say 3s. You need a 3s, not 3r. So you have to flip this chlorine with hydrogen. So hydrogen is not away from you. It's actually pointed to you. The chlorine is away from you. So then this is S. That's correct configuration. So final answer should be this one. Okay, you don't have to show the hydrogen. Just draw this bromine and chlorine. You can also have a different structure as a correct answer. For example, this is basically vertical flipped of this answer. So it's correct. So you can also draw other correct structure. Okay. Last example is another cyclic. So this is 1R, 3R, 3-ethylcyclopentanol. So first you draw the basic structure, right? So that's a 3-ethylcyclopentanol. Now worry about the absolute configuration. So this is carbon 1. Assume the hydrogen is away from you. So assign priority first based on the CIP rule. 1, 2, 3, 4. 1, 2, 3 is counterclockwise. So this is S. However, you want R, so you want switch this to group, switch the hydroxyl group away from you, hydrogen point to you, then correct R. Then the other asymmetric center, assume the hydrogen is away from you, and then priority, this is a 1, 2, 3, 4, based on the CIP rule. And then that's 1, 2, 3, 1, 2, 3 is clockwise, so this is R, and this should be R, so that's correct. The assumption is correct. So the answer should be here. You don't have to draw the hydrogen again. So you can also draw the other way. So basically also flipped vertical. Okay, that's all the information or all the examples. I want to show you the absolute configuration. If you have any questions, please let me know. Okay, good luck.